Okay, physics 1.1 to 1.7 course questions document. We're gonna go through these a bit quicker because yani, their questions are pretty similar to those in the quiz. Which of the following are thermometric properties? And I'm gonna go through the solutions at the same time. Give a reason for each one. The hardness of egg white, akid no. Why? Because you can't reverse it. Although the hardness of egg white, you can change it. You can't, yani you can't change it back. You can't reverse it after you cook it. The length of mercury in a mercury in glass thermometer, yes, it is because you can measure the length of it and you can change it upon heating. When you change the temperature, the length will change. The mass, remember, thermometric is something that can be changed and measured. The mass of a fixed quantity of gas, no, it is not thermometric because it is always constant. The mass of a fixed quantity of gas remains constant. Okay. Question two. Describe an experiment used to check the calibration of a Celsius thermometer. What are the correct safety procedures that you need to be aware of? Explain. And I'm going to go through the solution. Okay. Insert the bulb of thermometer. Oh, well, we need two things to calibrate a thermometer: the ice point and the steam point, right? How do we find the ice point? Step one: insert it in melting crushed ice. When mercury stops shrinking, mark the thermometer. In this case, how much will it be when it's with crushed ice? 0 degrees Celsius. Okay, خلصنا. Now insert it inside a flask containing boiling water. Okay, so that the bulb is just above the boiling water. Okay, if this comes written and you put with boiling water, you're gonna get it wrong. Above the boiling water. Okay, this is the steam point. When it stops expanding, we're gonna mark it. How much should this be? 100 degrees Celsius. What are the principal hazards? What are they? The precautions. Henny, fragile glassware, toxic mercury, and extreme heat. Okay. وين رحت انا X and Y are liquid in glass thermometers. Okay, the scale of each thermometer starts at 0 degrees Celsius, has a large range, good linearity, and high sensitivity. Y has a small range, poor linearity, and low sensitivity. Explain what is meant by the difference in the ranges, the difference in the linearity, and the difference in their sensitivities. This I don't think it will come, but just in case. Okay, difference in ranges means the range of something is how far it can go, right? It's range, like the range of numbers, the range of the football field. It's how far it goes. Okay, so thermometer X goes to a higher temperature. That's what it means that X has a higher range than Y. How about linearity? Okay, if it has poor linearity, that means I don't think it's precise. Liquid in X expands uniformly. Oh, okay. Linearity means it expands in a uniform way. For example, some liquids they can expand only like this is the liquid. Okay, just let's imagine it. If it expands linearly, that means it expands straight like this, continues straight. If it doesn't expand linearly, it's gonna expand like this. So what's this? We don't want this. Okay, so if X has a better linearity than Y, that means X expands uniformly. What is meant by sensitivities? X is more sensitive than Y. That means for the same temperature rise, liquid in X expands more. If you're sensitive to something, yani you have a greater response to that change. Okay. Describe how the ice point and steam point are located on a thermometer. Quickly, the ice point corresponds to the tip where it's in thermal equilibrium with what? Melting ice. And how much is it? It's 0 degrees Celsius. Okay. So if you want to say this in written, quickly you can say it's the tip of the mercury column when it's you can say when the thermometer is in thermal equilibrium with melting ice. Okay, and make sure to remember at a pressure of 1 atmosphere. Okay, at a pressure of 1 atmosphere. Those are the conditions. And then you say the temperature at this point is 0 degrees. Okay, the steam point is when the tip of the mercury column is in thermal equilibrium with the steam above boiling water at a pressure of again 1 atmosphere. And what's the temperature here? 100. Okay, these are in case they come written. Describe the working principle of a liquid in glass thermometer. What is the principle here? Liquid in glass thermometer uses the principle of expansion of substances, right? Thermal expansion of substances. Okay, a liquid in glass tube expands when heated and contracts when cooled. A calibrated scale can then be used to read off the respective temperature that led to the corresponding thermal expansion, blah, 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 blah. Okay, pretty self-explanatory. If you heat it, it expands. If you cool it, it contracts. In the exam, they said what do you call it? Characteristic does the thermometer use in this case? And you had to say the volume of the mercury. Okay, the volume of the liquid inside the thermometer. It came in the CA. Describe an experiment supporting Boyle's law. Okay, use apparatus on page 6. Okay, yeah. This came in the CA. Okay. Uh, I got it wrong, to be honest, and I got it wrong. Okay. Here's what you're gonna do. You're gonna use the apparatus on page 6. And they gave you the apparatus on page 6. I'll show you how it looks like. It's this one down here on the left. Okay. They gave us this in the exam. They asked which of the following is true. Here is what was true. The pressure can be read on the boarding gauge and the corresponding volume from the vertical volume scale. That's two choices. One choice was read the pressure on the boarding gauge, and then you can read the volume of the air from the vertical volume scale. Okay, then we say that V against 1 over P is plotted. It's a straight line passing through the origin. Okay, these were the three choices, and I got it wrong because صراحة I didn't study this. Okay, man, I was in the bathroom when we took this in class. It wasn't on my luck, wasn't on my side. A gas is heated in a closed container so that its volume cannot change. Which of the following will not happen? Okay, it's being heated. The average speed of the molecules will increase. Akid, it will happen. The molecules will move in all directions. This should happen as well. The number of molecules will increase. Akid, that will not happen because it's in a closed container, so its volume will not change. So if I'm not wrong, yeah, mass will remain constant. Remember that the mass of a closed gas is always constant. The pressure of the gas will increase. Okay, yeah, the pressure will increase if you're increasing the temperature, blah, 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 blah. What is the relation between Kelvin and degree Celsius? Kelvin, you can just write it like this. Okay, Kelvin equals degree Celsius, which is represented by theta, plus 273.15, or you could just say plus 273. Okay, it does not really matter. But in the solution, they put 273.15. Put 273.15 if it comes written or in a typing. Draw and label a thermocouple. I feel like they could get this in the written. I don't know why. Draw and label a thermocouple. It will look something like this. And you have to mention that wire W and wire Y are made up of the same material. Okay, and then Z is made up of a different material. Okay, and describe the properties. What are the properties? We say it has low heat capacity. Okay, three things. It's probably going to be a 3-mark question if it comes written. Low heat capacity, okay. Sensitive, very sensitive, okay, and has high precision. Yeah, there it is. So low heat capacity, high sensitivity, high precision. What are they? Low heat capacity, high precision, high sensitivity. Why is it low heat capacity? Which makes them respond quickly to the changes in temperature, right? Okay, it makes them respond quickly to changes in temperature. That was low heat capacity. Means low heat capacity, yani it doesn't need much energy to change its temperature. What else? It's high sensitivity. High sensitivity معناتها if something is sensitive, yani it will respond it will respond greater. It will have a greater change in temperature over a wide range of temperature. Well, high precision. High precision معناتها what? It's exact result. Okay, it's not. It's very accurate. Yani it's very accurate. High sensitivity, high precision, low heat capacity. Okay. Question 10. Answer by true or false. The temperature of an object is a measure of the average kinetic energy of its molecules. I think this should be true. Yeah. Remember that absolute temperature is directly proportional to the average kinetic energy. Moving a body increases kinetic energy, thus making it hotter. Akid, yes, true. The molecules of a hotter object have a higher concentration of heat energy than those of a colder object. Akid, true. Fast moving molecules have a higher temperature than identical but slow moving ones. Identical. Yes, akid, it should be true as well. Yes. Bodies can become hotter by converting their mechanical energy of macroscopic motion into the kinetic energy of their molecular random motion. Is the converse true? Let's forget about the converse for now. This is true. What does this mean? Mechanical energy, remember, is yani moving around, moving. Mechanical energy from grade 10 physics is equal to kinetic energy plus gravitational potential energy in mechanics. Okay? So always associate mechanical energy with movements. Okay, can you convert mechanical energy into kinetic energy? Yes, of the molecules random motion. The converse is false because the random kinetic energy cannot be converted into mechanical energy. It's random, so you can't really do it the other way around. Just memorize it in case it comes. Okay, this could come true or false in the multiple choice in the computer part. Okay, we don't really have much left. 1, 2, خلاص, this question over here. So we have 2.5 pages left. A hot piece of iron of mass 5 kilograms at temperature 60 is placed in 3 liters of water in a copper pot of mass 1 kilogram. Okay, at room temperature 300. Determine the equilibrium temperature of the system. Neglect energy losses to the surroundings. So for this question, it's very important to know what you're working with. Okay, I'm gonna start by showing. أول شيء we have more than one system, right? عنا السيستم of the hot iron. Okay, let's call this I. وعنا السيستم of the water and copper, right? Okay, and we're saying the iron is mass is 5, so this is M of I. Well, temperature of I is 60 degrees Celsius. The other one is in Kelvin, so let's just convert this into Kelvin from the start. 60 plus 273 is 333 Kelvin. So this is the T. And it's placed in 3 liters of water. You guys know that for 1 liter of water is 1 kilogram of water because the density of water is 1. Okay, so 3 liters of water is the same as saying 3 kg water. Okay, and a copper pot of mass 1 kilogram at temperature 300. Determine the equilibrium temperature. Equilibrium temperature. Whenever you see equilibrium temperature, thermal equilibrium, معناتها Q gained equal Q lost. Q gained equals Q lost. Which one is the hotter one here? It's the iron. So the one that's going to be gaining energy is أكيد the colder one. Okay? So which one's going to be gaining energy? It's going to be the water or the water and the copper? It's the water and the copper as one system together. It's water and copper together because it's a copper pot. So it's water inside the copper pot. So the water and copper is being treated at the same time as one system because into you're adding iron. Iron is the foreign material, is the new external factor that you're adding. What we originally had was water and copper together. So Q is equal to MC delta T. But since I'm working with a system, we have to find the C for the system. And how do we find the C of any system? Okay, in this case, it's water and water and copper. How do we do it? It's going to be C of water M of water times C of water plus M of copper, say CO, plus, ya Allah, M, not plus, M of copper times C of copper. This was in my notes. To find the heat capacity of a system, you do MC of the first one plus MC of the second one. If it's three things in the system, plus MC of the third one, and plus MC of the fourth one, plus MC of the fifth one, and so on and so forth until you're finished. Okay, so the C of the system is M of the water, C of the water, plus M of the copper, C of the copper. So in this case, Q equals MC delta T, right? Instead of MC delta T, we're going to say C delta T because it's the big C, right? When you're finding the C of a system, that's actually the big C. And what do we do when you have big C? We don't say MC anymore, we just say C. Okay, so Q equals C delta T. Okay, here they didn't give it to you, but they expect you to get it from the book, but in the exam it will be given to you. We're going to write C. We're going to write it here on the right. C of water is 4.2. C of, what do you want? Iron is 0.48. And C of copper, CO, is 0.39. Okay, let's go back here. Let's solve now. Okay, the mass of water is 3 kilograms, right? The C of water, we know is 4.2 kilojoules. Plus the mass of copper, which is 1, so we don't have to write it, times the C of copper, which is 0.39 kilojoules. You're going to get here, it's going to be equal to 12.99. Okay, so our big C here is 12.99. So Q equals 12.99 delta T. Okay, what was the temperature? We know delta T is final minus initial, right? Okay, bigger minus smaller. It would be better for delta T to do bigger minus smaller. And we know this one is hotter, this one's colder, so this is going to increase. So 300 is the smaller one, so it's going to be the bigger temperature, which is the final temperature we get, minus 300. If you do it the other way around and you don't really care, you put absolute values. And I don't want to put absolute value, so I don't confuse you. It doesn't matter the order you put it, as long as you make it positive. If you get a negative answer, make it positive. Okay, so we say TF, final temperature, minus 300. Okay, this is Q gained. Q gained. How about Q lost? Which is going to lose energy? It's the iron, right? So again, M of iron, C of iron, delta T. Okay, what is it going to be? The mass of iron, 5. C of iron, given 0.48, right? Well, it's supposed to be given, but we got it from the book. Times delta T. Bigger minus smaller. It started with 333. Since now it's gonna lose energy, it's gonna give energy to this 300 here. The bigger one, it's yani, is obviously gonna be 333. 333 minus temperature final. Okay, 5 times 0.48 is 2.4. So 2.4 times 333 minus TF. نحن, we know they're equal to each other. So what will we write? 12.99 TF minus 300 equals 2.4 333 minus TF. If you have a calculator that can solve equations, you can put it in the calculator and just press shift solve. You're going to get 305 point something. If you don't, and I'm not going to solve it, صراحة ما قالي خلق. Okay, I'm not really in the mood. You're going to get T equals 305. If you don't know how to solve, distribute this 12.99. Okay, distribute this 2.4 here into both. Then you're going to get, I did it on my copybook. It's 12.99 TF plus minus 3897 equals 799.2 minus 2.4 TF. Take this minus here, take this minus here. It becomes 12.99 plus 2.4 because it became plus on the left. It will be 15.39 TF equals this plus this now خلاص 4696.2, and then you divide by 15.39 on both sides. You get TF is 305, I think, point something 6, I think, or 0.4, whatever. But round it, you're gonna get 305 in Kelvin. Huh? Question 12. A 2.2 kilogram piece of lead is placed in an aluminum beaker of mass 500 gram containing 10 liters of water. An electric heater of power 2000 watt is used to heat this system from 20 to 80 in 21 minutes 22 seconds. Determine the specific heat capacity of lead. Give one factor that explains the difference between the calculated value and the actual one, and state how it does, and so how you can reduce the effect. So for this one here, since you're working with an external heater, okay, it's not you're adding something and then thermal equilibrium وما بعرف شو, لا, okay, here you're adding a thermal heater, you're adding an external heater, so the heat is coming from outside, okay, and you're heating this whole thing as one system. What is this system made up of? So we know that the heat, we're heating the system from 20 to 80. This system we're making up of, let's say called Q total, is equal to the Q to heat up the lead. So let's say the lead, Q of lead, plus the Q, the energy, and he needed to heat up the water, Q of water, plus the Q needed to heat up the aluminium, Al, right? Okay, we know that the Q total is equal to how much energy our electric heater supplied. And how can we know how much energy our electric heater supplied? They gave us the power and they gave us the time. Remember that energy equals power times time, right? Remember this all the time. All the time. Anyway, shit, why am I laughing? Yeah, anyway, we can find this on the calculator. The power is 2000 times the time, it has to be in seconds, which is 21 times 60 to convert 21 minutes to seconds, plus the 22 seconds extra. You're gonna get this. Let's make this into kilojoules. So let's divide it by 1000 and make it kilojoules. You're gonna get Q total is actually 2564 kilojoules. Okay, Q of lead. What is Q of lead equal to? What is Q equal to in general? MC delta T, صح? So the mass of lead, which is 2.2, times the C of lead. We don't know what the C of lead is. We're actually trying to find it in the question. The specific heat capacity of lead. Times delta T. كل الدلتا T's, all the delta T's will be the same. 80 minus 20, 60. Plus Q of water, which is, again, MC delta T, the mass of water, 10 liters, yani 10 kilograms, times the C of water, which is 4.2. It should be given, but it's in the book, so it should be given in the question. Times delta T, which is 60 for all of them. Q of Al, the mass is 500 grams, so 0.5 kilograms. The C of aluminum is 0.39, صح? No, 0.9. Yeah, 0.9. Okay. Times delta T, which is 60. Okay, let's simplify this a bit. It's a bit crowded. 2.2 times 60 is 132, I think. So 132 times C lead. So 132 C lead plus here 42 times 60 42. I don't know how much is that. I'm gonna use a calculator. ما لي خلق. 42 times 60 2520. Okay, plus 0.5 times 0.9 times 60 27 equals the Q total, which is 2564. Okay, 2520 plus 2 plus 27 is 2547. We have 2564 over here. We have 132 C lead. Okay, let's minus by 2547. You're gonna get 2564 minus 2547. That's 17. So 132 C lead equals 17. Divide 17 by 132. You get 0.1287. Why is it 0.21? Let me see here. Okay, so after taking a look at it for a bit more, um, they used the C of water in the solution as 4.18, which is common. People will do that. But it's not my mistake. If you use this and get your answer at 0. I don't know, we got 0.13, I think, kilojoules. Remember, the unit of heat capacity is Q divided by M, so it's kilojoules per mass, which is kilogram, K negative 1. This is the unit. You need to know this. 100%, you have to know this. Okay? If you get this answer, you're going to get it correct because they didn't give you a C of water, but in the exam they will give you, and if you just plug in the proper C of water, and I plugged in now 4.18 as the C of water here, and I got it correct. Because people do that, you know, sometimes they use 4.18. Very, very stupid. I don't like these types of questions. Design an experiment to determine the specific latent heat of vaporization of water using an electric heater. Why don't we need a thermometer? Okay, latent heat of vaporization. We need an experiment for it. Let's see. Connect the immersion heater to the power supply, fill it with water, cover it, and weigh the total mass. Remember, we did this in the notes. Insert the heater and heat until water begins to boil. Remove the lid so that steam escapes, and at the same time, read the joule meter so we know how much energy, right? After 15 minutes time, switch off the heater and replace the lid. The mass of the water converted to steam is the mass 2 minus m1, right? Mass 2 minus m1, so we know how much steam escaped. Find L using Q2, like Q2. Okay, see why I don't like the physics course revision is because they بيخبصوا كتير, like they make a lot of mistakes. They're supposed to say this here, يعني put this sentence should be over here. Okay, so replace the lid. Okay, then when you replace the lid, you read the joule meter again, Q2, and weigh the beaker again with lid. So you get the new weight. This is after the steam escaped. You subtract the new weight minus the old weight to find out how much steam escaped. So let's say M1 was like 700 grams, and this is now 705 grams. You subtract them, that means 5 grams of steam escaped, right? So the mass of steam that escaped is 5 grams. We know that sorry, the equation for latent heat of vaporization is Q equals mLV, right? Okay, how do we find LV? LV is Q over M. Okay, how do we find Q? It's actually, we had the first energy level. Let's say when we, what do you call it? Yeah, when you remove the lid, it was, let's say, 100 kilojoules. Okay, and then after you close the lid and weighed it again, it was 110 kilojoules. Okay, مثلا. Okay, we want to know how much energy you just subtract is 10 kilojoules. So can we find LV? It's 10 divided by 5 equals 2. This is random numbers. Okay, the numbers will not be this easy in the exam, but say I'm trying to give examples. Okay, so what do? We put water in a beaker, close the lid, boil. Okay, when you lift the lid and you read the joule meter, close it, okay, then weigh the final weight, subtract the final weight minus the initial weight, add the final joule meter by the initial joule meter, and L will be Q over M. So it will be Q, which is final energy minus initial energy over final mass minus initial mass. Okay. This one is أكيد for latent heat of fusion. They say why don't we need a thermometer in this experiment? It's because نحن يعني there's no change of temperature during evaporation. Oh yeah, no thermometer is needed because there's no change of temperature during evaporation. Evaporation, it stays like this straight, right? Okay, it stays over here. Okay. Uh, Question 14, to find an experiment for latent heat of fusion. Okay, نفس الشيء. Connect the electric heater to its power supply. Put ice of known mass, okay, into a thermal flask containing water at 0 degrees Celsius. And upon heating, okay, keep stirring. Okay, we want to turn on the stopwatch when the heat starts, right? Okay, record the values of the current and voltage. Once the ice has just melted, turn the heater off and record the time it took to melt. The heat energy supplied, remember Q is IVT. And then how do we find latent heat of fusion? It's IVT divided by the mass because it's Q over M, which is again Q is IVT, so IVT over M. Okay. Remember, نحن we're melting. Remember, latent heat of fusion when you melt, so that's why we put ice cubes. Okay, we turn on the heater, wait, measure the time it took to melt, measure the current, measure the voltage. We can find the energy, so IVT divided by the mass. We know the mass. Okay, the mass of the ice cubes, huh? The thermometer is not needed because there's no change in temperature during melting or during fusion. What is evaporation? Let's describe evaporation. A liquid, it evaporates not only at its boiling point but also at any temperature. This could be the first multiple choice answer. The difference is that at the boiling point, evaporation takes place anywhere within the body of the liquid, okay? Whereas at lower temperatures, it only takes place at the surface. These could all be answers to multiple choice. Evaporation is always accompanied by cooling. When something evaporates, it cools down the body. According to the kinetic molecular theory, the potential energy of the particles that leave the liquid increases. This happens at the expense of the molecules that stay in the liquid state. Only the more energetic molecules near the surface leave the liquid. The remaining molecules will have a lower average kinetic energy and therefore a lower temperature. Let me explain this, okay? When a liquid turns into a gas, you know that gases have further apart molecules. And what does this mean when distances between the molecules increase? When distance increases, that means potential energy of the molecules will increase because the distance increase. This is a rule in physics. When the distance between atoms increase or distance between molecules increases, معناتها potential energy تبعتها it increased. Okay. Okay. What else? Why did it increase? You know that energy is always conserved. طيب, it increased here. So where did it take this energy from? It took the energy from the molecules that are still in this cup of water that still did not turn into gas, that are still liquid. Okay, so it stole the energy from there. Since you're losing energy, what happens? The temperature cools down. Okay, this is just to explain it. So that's what they meant. It happens at the expense of the molecules that stay in the liquid state. Only the more energetic molecules near the surface leave the liquid. The remaining molecules will have a lower average kinetic energy and therefore a lower temperature. This is for when it happens at any temperature, not at the boiling point, huh? أكيد the more energetic ones will be the ones who leave. The remaining molecules have a lower average kinetic energy and therefore a lower temperature. Blah, blah, blah. Define specific heat capacity. What is the specific heat capacity? We know specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius, right? How much heat is needed to raise the temperature of 5 kilograms of a substance of specific heat capacity 3, okay, by 10 degrees Celsius? Quickly, we apply the formula. Easy, direct application of MC delta T. Okay, the mass is 5, the C is 3 times 10 to the 2, and the delta T 10 degrees Celsius. Okay, you're gonna get 1.5 times 10 to the 4. Okay, question 18. هول الجريدز كتير مهمين, very important. Okay, the diagram below shows the variation of temperature with time of a substance heated at a constant rate. Okay, which part of the graph corresponds to the substance existing in two states at the same time? Give an explanation. أكيد A, B, or C, D. What is the explanation? And I have my own explanation, but I'm not sure if it's correct, so let me see the solution one. The parts corresponding are A, B, and C, D. Why? Okay, yes, because during a phase change, the temperature of a substance does not change. This corresponds to the horizontal lines A, B, and C, D. Okay, we know, just say if it, I don't know, I don't think it'll come written. Maybe it does. Okay, during the phase change, temperature does not change. That's it. Calculate the time required to vaporize 0.5 kilograms of water at 100 degrees Celsius with a 1.5 kilowatt electric heater. Neglect heat losses. Take the latent heat of vaporization to be 2.3. So we want to vaporize 0.5 kilograms of water. Okay, we know that to vaporize, it Q equals mLV. Okay, the mass of water is 0.5 and the LV is 2.3 megajoules. Okay, 2.3 megajoules. If you want it, we want it to be in kilojoules. Okay, since this is kilowatt, let's make it kilojoules. So you multiply by 10 to the power of 3. Okay, because mega is 10 to the 6, kilo is 10 to the 3. What's the difference between them? 10 to the 6 divided by 10 to the 3 is 10 to the 3. So you multiply by 10 to the 3. 2.3 times 10 to the 3 is 2300. Okay, and you get 1150 kilojoules. So Q is equal to 1150 kilojoules. بس نحن بدنا التايم. Okay, what did we say? Q is equal to, we said it's equal to power times the time, right? Okay, so do I have the power in a horn? Let's take a look at the question. Oh, I just broke my pen. Hold up. Hold up. How did it break? Okay, I fixed it. Okay, yeah. Let's look at the question. Do I have power? Yes, I do. It's 1.5 kilowatts, right? So 1.5 times the time in seconds equals 1150. Let's divide 1150 divided by 1.5. It should be 1000. Let me see. 1150 divided by 1.5. You get huh? Oh yeah, okay, yeah. You get 766.6 seconds. So it should be 767 seconds, I guess. Yeah. Oh, okay, yeah, 767 seconds. Okay. Define specific heat. No, define specific latent heat of vaporization and fusion. Okay, the latent heat of vaporization or the latent heat of fusion is let's start with latent heat of vaporization. It's the energy needed to change the state of an substance from solid to no, vaporization is liquid to gas, and the fusion will be the energy needed. Yeah, to 1 kilogram. صح. I forgot about the 1 kilogram part. So the fusion one is the energy needed to turn 1 kilogram of substance from solid into a liquid. How about vaporization? Is to turn 1 kilogram of substance from liquid into gas. Okay, we're almost done. يلا قربنا نخلص. Okay, a compound strip of copper and iron is straight at room temperature. Give a label diagram and explains what happens when it is heated. Okay, so I'm just going to open the answer key for this. It's straight at room temperature. Copper has a greater expansion coefficient and hence expands faster than iron. So the bimetallic strip bends down. So here, it doesn't matter which one's up, which one's down. Okay, but if you put copper up, like it should be given that the alpha of copper is, let's say, I don't know, 24, and the alpha of iron is like 16. Okay, you can draw this anything, just two rectangles above each other, put copper up, iron down. Then he said what happens when it heats. You know, when it heats, copper, since it has a bigger alpha, it will extend like this, more, it will extend more. Well, since iron has a smaller alpha, it will extend like this. So to fill up this empty space here, it's gonna bend downwards. That's how you know. Draw this part in a scratch paper so you know. Okay, don't draw this on your actual paper, draw on the scratch paper on the side. Okay, so when it's gonna bend downwards, so that's why we know it's gonna curve downwards like this. Okay. Question 22. A wire is held between two pillars as shown below. The wire is connected very tightly. Okay. What would happen if the weather becomes too cold? Explain your reasoning. Yeah. What happens when something becomes cold? It shrinks, right? What happens when you cool a metal? It shrinks. And since it's very tight and it won't be able to shrink, what's gonna happen? It's gonna break, right? So therefore the wire will most probably break. So this could come into exam. Why would the wire break if the weather was too cold? You'd say in the multiple choice, it would be a multiple choice, because at cold temperatures the metal shrinks. I don't know. 1.7. A red woolen jacket, a steel sword, and a black piece of coal have been placed in an insulated room for a sufficiently long time. Which object do you expect to be the coldest and why? So they put it in an insulated room for a sufficiently long time. Okay, which is the coldest? A red woolen jacket, a steel sword, and a black piece of coal. All will have the same temperature because at thermal equilibrium, all bodies in an insulated system end up with the same temperature. Here's the trick. أنا صراحة I got a bit confused when I read it. But the trick is insulated room. Insulated room معناتها the room, let's say it's 35 degrees Celsius. and it's insulated. يعني you have this layer of, I don't know, vacuum or whatever, and you place all the objects in the room. أكيد if it placed for a for a sufficiently long time, أكيد all the stuff inside that room, all the things in the room will change its temperature to become with thermal equilibrium with that 35 degrees Celsius. So everything will now be 35 degrees Celsius. Okay? So which object will be the coldest? All of them will have the same temperature since it's an insulated room. It will reach thermal equilibrium. Can two bodies at thermal equilibrium exchange energy in the form of heat? No, since it's in thermal equilibrium. They can exchange energy mechanically. Mechanically, يعني by moving. Okay, this could come. Actually, it actually could come. Okay, it could come as a part A, part B question. Okay, use the kinetic molecular theory to explain the transfer of heat by conduction. What did we say? We explained the flow of heat by means of this could come fill in the blank, huh? By means of the kinetic molecular theory, by imagining the faster moving molecules in the hotter parts of the matter collide with the slower moving molecules in the colder parts. They collide with them, thus passing on to them a part of their kinetic energy. Okay. Explain why the transfer of heat by conduction in metals is fast. Why? Because they have free electrons, right? The free electrons in metal are not confined, but are free to move throughout the body of the metal. If a part of a metallic object is hotter, the free moving fast electron from the hot part will move across the body of the metal and thus carry the thermal energy from the hot part across the body much faster than it can be transferred from molecule to molecule by molecular collision. Okay, that's what helps the solid have the upper hand in conduction, because they have free electrons. But liquids and gases, they can still conduct, but very slowly. They're going to use the molecule to molecule method. But the solid not only uses the molecule to molecule method, they also use the free electron method. Question 26. In order to investigate the thermal conductivity of water, the following experiment is conducted. Ice cubes are held in place at the bottom of a beaker using a metal mesh. The beaker is filled with water and the heat source is placed near the top of the beaker. Here, the metal mesh is covering the ice at the bottom. Here you have heat, whatever. The experiment shows that the water at the top of the beaker starts to boil into steam, while the ice at the bottom of the beaker remains intact. What conclusion can you make? Water is a poor conductor. Okay? Water is a bad conductor of heat. The ice didn't melt, so the heat was not transferred from the top to the bottom. That means water is a bad conductor of heat. Like this, بنكون خلصنا. يعطيكم العافية. Okay, I'm done recording for the physics periodic now. It's a long day of recording, wallah. Thank you so much for watching. I will probably be going live before the physics periodic on Sunday to answer any questions for 1 hour, probably at 7 o'clock UAE time or 7:30 UAE time. For 1 hour until like 8:30 UAE time. Anybody who can have any questions, you can join the live then. Thank you so much for watching. Good luck.